Bro,
Okay, can we start?
yes,
All right, first of all, let's just understand the concept of linear momentum. Do you know the idea about linear momentum? What do you mean by linear momentum?
no,
Usually, we talk about kinetic energy, mechanical energy, about energies. And I said yesterday that kinetic energy represents speed, potential represents height, if you can just remember this idea.
yeah,
Now, the concept of linear momentum, let's just take this figure. Assume that you have this elephant moving with a speed and another object, which is a bullet, moving sure with a different speed. And for sure, the bullet will be moving with a very, very high speed compared to that of the elephant. But now, if we want to talk about the linear momentum, the product, as you can read here within the last two lines, the product of these two quantities represent a physical quantity called the linear momentum. So this is something new. It's not kinetic energy, it's not potential energy, it's just the concept of how much this object is moving fast and taking into consideration the mass of this object. This is the product. The formula used is P equal m times v. P represents linear momentum, m represents the mass, and v represents the velocity. All right?
yeah.
Let's take this question, first question from your PDF file. How many times greater is the linear momentum or is the momentum of a 1500 kilogram mass hippo moving at 0.25 meters per second than a 75 grams mass bird flying at 10 meters per second? First of all, it's very important to just summarize the concept. So we have mass of the hippo, I'll just write h, equal 1500 kilogram, and the speed is v equal 0.25 meter per second, also vh. And then we have another object, which is a bird. I will just write b. So mass of b is 75 grams, and the speed v equal 10 meters per second. If we just make a difference or differentiation between them, the mass of the hippo is very large, about 1,500 kilograms with respect to something with grams, very, very small object, the bird. And here the speed is too small for the hippo with respect to the speed of the bird that is fast. Now, we must calculate the linear momentum for each of these two objects. So if I start with the first one, linear momentum of the hippo, pH, will be equal to mv for the hippo. And the values will be 1500 times 0.25. And now we'll calculate or find the answer. And
What
then
is
we'll,
the pH?
yeah,
pH?
repeat please. What is the meaning of
What is pH?
pH? This is the linear momentum or the momentum. So P is the momentum and H represents the animal, which is a hippo. Okay?
Yeah,
And B represents the bird. Once I write B, I'm just meaning by a bird. All right. Now, the value, we can calculate this value and we'll get 375. And sure, the SI unit will be kilogram meter per second. Now to compare it, we must find the linear momentum of the other bird. So P of the bird will be equal to the mass of the bird multiplied by the speed of the bird. And then we can find the result. Mass is 75. We must change grams to kilograms. Do you know how to change grams to kilograms?
uh, yeah. 1 second.
Yeah, I'll wait. Do we divide or multiply?
From gram
Yeah, to
or from
kilogram. Which one you know changing from kilograms to grams or grams to kilograms?
We move the decimal
Yeah,
to
that's
the
right.
left.
Perfect. So we move it 3 times. So it will be
Yeah.
0.075 kilograms. So as if we are just dividing by 1000.
Yeah.
Okay, then we multiply 0.075 times 10, and the answer will be 0.75 kilogram meter per second. Now, till now, we didn't finish, since we must find the relation between this one and that one. So just go and divide P, or the linear amount of the hippo, by the P of the bird. So it's 375 over 0.75. And the answer will be 375 divided by 0.75. And you will get 500. What is the meaning of 500? Then 500, the linear momentum, I'll just write it as a sentence. The momentum of the hippo is greater than that of the bird 500 times. All right,
Yes.
let's check the answer here on the PDF file. And here it shows 500 times is the correct answer. Okay.
Yeah.
All right. Let's now move to this part. I will try to finish electricity and magnetism before I move back to the forces that we were working with yesterday.
Okay.
Okay. Electricity and magnetism. Just remember, usually if we want to create electromagnetic materials, we need electricity and we need something like a coil. Here they said that this person has made an electromagnet. He wants to add a core to the coil of wire to make the electromagnet stronger. So in order to add a core, they must add something inside this coil. The best material to create an electromagnet is to search for something very or high conductivity. So between these four materials, it's not the wood, it's not the plastic, and it's not the aluminum. It's the iron. So the correct part is the
What
part
do
C.
they mean with the core? What is the core?
Okay, let me just try to show you a picture here from the Google directly. It's a material, they use it to create an electromagnet using a coil and electricity. I'll try to show it here just as a figure. Core in a coil. Okay, if you can just take a look here in this picture,
Ah,
this one
okay.
we call it as a core. Usually they can create a core by something not conductive, so like papers, like plastic, like air. But
But
to
it will
create,
burn if it's paper.
yeah, to make it perfect one for an electromagnet, it must be something conductive like iron. Now, which of the following shows the correct way to use compasses to plot the magnetic field of a bar magnet? Just remember, I'm not sure if you remember the magnet and how it works. Usually a bar magnet will be formed of two parts. One of them
The
we call
plus
it, yeah,
and
usually,
negative.
perfect. We usually name them as north and south. The one of the sides will be named as north and the other will be named as south. Usually we have another thing, we call it the charges. Charges might be positive, might be negative. They can attract, they can repel. Similar to magnets, they can attract or repel, but the right side, we call these charges. This one, we call it as a magnet. So remember something, from magnets, the magnetic field will be just moving out of the north and this magnetic field will enter to the south. this is the way how magnets work. Let's check the figures here. So the first figure, they said, which of the following shows the correct way to use the compasses to plot a magnetic field of a bar magnet? Let's start with the first figure. As you can see here from part A, remember, magnetic field lines will go out from the north and they will enter to the south. So if I try to just draw some lines, they must be leaving from the north and entering to the south. So that's correct. Here it's entering from the blue, entering to the blue, entering to the blue. In general, this figure is almost correct. In general, it's correct. Although some of them, they are not, like this one, like this one. It must be flipped, but it's okay, accept it since there is a small mistake. But if you go to the other figures, look here, it's not correct since the lines must be going out from the N. So we must see lines here, and they didn't draw these lines, and they must be entering to the S. If you go to the other figure, here, it's totally not correct. These are vertical. This is not the case.
Yeah. Yeah.
Okay. Do you have any question about magnets?
No.
Okay. Let's check about charges. Here they said that the diagram shows two charged particles. Red indicates a positive charge. And they said, just remember, similar charges repel, different charges attract. Okay? So if you have plus and plus, they will create repulsion. All right? So plus with a plus, they will repel. They will go away. Minus and minus, they will go away. If we have only different charges, they will attract each other. So here, attraction. Here, repulsion. All right?
Okay.
So if we have different charges, do you expect that they will attract or they will repel?
Different charges, they will
Yeah.
attract.
They will attract. So part B is the correct answer. Yesterday we mentioned about the SI units. So here the SI unit of current is ampere. Volt is for voltage, joule is for energy, and watt is for power. Do you know these, or you want me to write them as a summary?
Yeah, I know them.
Okay, great, great. We still have maybe some parts about state of matter and density. Let's finish them directly before we move to the hard part about yesterday. State of matter or states of matter. A gas does not have a fixed size or shape. It's correct, since if you just place a gas, certain gas, in a square shape, they will take this shape. If you place them in a cylindrical shape, they will take the same shape as a cylinder.
Yeah.
What is the process of changing a solid to a liquid? It's totally just if you want to draw as a quick from solid to liquid to gas. We name this process, the last one, as evaporation. This one as melting. So changing from solid to liquid, we call it melting. Solidifying, which is the opposite, changing to a solid, from liquid to a solid. And freezing takes the same meaning as solidifying or solidification. All right?
Okay.
Okay. Let's check this application. In this application, they said the density of aluminum is 8,000 kilogram per meter cube. Find the volume of 100 kilogram block of aluminum. Let me just take the whole set and place it here. So there is one formula, try to memorize it, which is density equals to mass over volume. If you want to memorize this formula, usually they write the shape of M like this, similar to a heart being cut it into two parts. So this one represents the mass, and this one represents the V. Now,
Yeah.
they said that the density is 8,000 kilogram per meter cube. So the density is given, and the mass is given. We must find the volume. Just flip V and rho. So it will be V equal to M over density. The mass is 100, and the density is 8,000. Cancel the two zeros, and it will be 1 over 80 meter cube, which is the first part. It's the correct part. Any problem?
How do I flip it?
Okay, it's easy. Look, how can we do that? I think that we have a formula, a new formula, A over B equals C over D. All right? And assume that you want to find in this formula, let's start with A. Assume that I want A. So keep A in its place and just do cross multiplication. So take B to C. So it will be B times C over D. This is the first case. Is this one easy?
Yeah.
Okay.
I know this one.
Oh, perfect. Now, if we want to find B, let's go to B. Let's keep B in its place and change the rest. So we will use the cross multiplication. So it's going to be keep B here and take it using this arrow to C. So the new shape will be AD equals CB. Till now, any problem? I'm just crossing as X. D beside A and B beside C. Is it okay?
Okay.
Now,
Yes.
keep this one in its place, which is B, and throw C downwards. So it will be, let me just write it on a new line. It will be AD over C equals to B. Usually, if you have any stuff in your home, you don't want it, you can throw it downstairs. So here, C, we don't want it. We want B. So you can throw C downstairs to the first floor. Okay?
Yes.
So it will look like this. The same process will be done for the formula density equal mass over volume. Now we want to find V. So just crisscross. Take V up beside rho. It will be like this. Rho V equal M. And we want to find V, so keep V here and throw density downstairs. It will be V equal M over rho. It's just some steps. Is it okay?
Yes.
All right. Let's move to the next part. Now let's talk about pressure, and these are the last two parts within this chapter. Which of the following represents a relation between pressure P, force, and area? And then they gave us such as an example. Let's explain a little bit about pressure. Okay, assume that you have a book like this. And assume that you have such like a sand here. If we just put the book on the sand, on this horizontal shape, nothing will change. But if I just flip the book and keep it vertical on the sand, let me show you the other figure that I mean it. Then we can feel the shape of this book in sand, right? You can feel the structure of the book in the sand. Is that right?
Yeah. Yeah.
Although the same weight and the same mass are placed on the sand. So what's the difference? The difference is pressure. So pressure is represented by the force over the area. So the force applied by this book is its weight. So the weight is constant. Let's say that this book weighs 10 Newton. So the weight is the same, nothing changed. But we are changing the area of this book. So if we place it in this face, which is the big one, the area may be, let's say, 10 meters square. So we have a big area. So 10 over 10 will be 1. But if we place it in this side, let's say the area is 5 meters square, then 10 over 5 will be 2. So the pressure is doubled, twice the initial pressure, so you can feel the shape of the book in the sand. Is it easy for now? Or you want,
Little.
do you want me to show some equation values?
Yeah.
Okay. Let's do this. Let me just get a file from my... Okay, assume that we have this figure. Man, I will just name this one as person 1 and this one as person 2. And let's take the area of the feet as, to make it easier, let's take the area equals to 10 meters square. Let's assume it for giving the calculations easier for now. So if I want to find the pressure for the first person, it's the force over the area, and the same formula, force over the area for person number 2. So the pressure for 1 and pressure for 2. It's the first force, and here it's the second force, and the same area. Let's say that they have the same size of the shoes, okay? So they have the same size. Now, the force of the first one, which is the weight. So the weight, which is, let's take
Can I
the
do it? Can I solve it?
Yeah, perfect. Can you show it to me on the screen? Can you try to draw or write?
I cannot write on the screen because
Okay, it's okay. Give me the
I will,
values at least, or read it. Yes.
I keep the P the same,
Go on.
P1,
Mm-hmm.
and then the force is 68 kilogram,
Okay.
and the area is 10 meters
Okay.
squared.
So I write here 68 and here is 10. All right.
Meter squared.
Meter squared. Okay. Just remember something here. They gave us the mass. So let me just write the weight here will be, okay, seconds. Let me just write the weight for the first person. It will be 680 Newton. And here the weight will be for 2, or the weight or the force, 1360 Newton. Since they gave us the mass and not the weight, so I'm just giving the weight. Do you know the difference between mass and weight?
Yeah.
Great. Go on, continue solving. So the first one is correct. The second one?
The one is 136,
Mm-hmm.
10 meters squared.
Okay, that's great. So the values here, it will be 6.8, and here it will be 136. Okay, the unit of pressure, we have 2 units of pressure. Either we can name it as Pascal, it's the first unit, and the second unit we can just use Newton per meter square. Both are correct units. If you just take a look here, sorry, hey, the 680, so it's 68. Okay, so if you can see here, this pressure for the person number 2, it's approximately twice the pressure of person number 1. So as
Right.
much as the mass increases, the pressure on the ground will increase more and more, right?
You add the 0 for the 68.
Yeah, I added the 0 since here we have the mass up. I will just show it. Here, there is the mass. So in order to find the weight, we multiply it by 10, the gravity. Here also, I multiplied by 0 to find the weight. In this exercise, they didn't give us the weight exactly, so it's totally different from, look here. The mass represents your mass on the balance. So the balance will give you, let's say, 80 kilograms, all right?
Yeah.
If you want to find the weight will be mg, so it's the mass times the gravity. So it's 80 times, we multiply usually by 10 or 9.81. So for this reason, I multiplied by 0 here, and I added 0 here.
You multiplied by how much? The 68?
By 10. So it will be 680 Newton. If you didn't take this formula, if you are not using it, don't worry about it. They will give you directly the weight and not the mass. Okay?
Okay.
Okay. Let's check the questions here. So which one of these 4 formulas is the correct one? A, B, C, or D?
I try to solve it.
Yeah, let me just take copy and I will show here the question.
The force is 25 Newton meters.
Perfect.
And the area is 4.
Perfect. Look here, just be careful. This is the radius. Can we find the area from the radius?
We changed it
How?
with pi, I think. I don't remember.
Yeah, that's right. So the area for a circle or cylinder it's pi r square.
I have the paper here.
Yeah. So
For
it's pi times radius. Here we must change it from centimeters to meters. So we change the point to zeros. It will be 0.04 square.
how is it?
Usually, if you want to change from centimeter to meter, you must divide by 100. So 4 divided by 100, you change it to zeros to the left. The point will go to the left. All right?
Yeah.
Okay. So here the answer will be, if we just substitute the pi times 0.04 squared, we'll get 5 point something. Let me just write here A. And if we divide 25 by the answer, we'll get, let's check the, yeah.
From where is 10.04?
Oh, okay. 0.04, from where did I get it?
Yeah.
Yeah, they said that the cylinder is made up of a radius 4 centimeters. So
Yeah.
this is the radius and not the area. Usually if you have an area, this is the radius of any circle. The area of this circle will be area equal pi r square. So you multiply pi by the radius square. Let me just take the values. Okay, here they gave you the choices with centimeters, so no need to change it. It's easier. Look here. They didn't ask for changing it also. So let's keep the unit in centimeter since the choice is in centimeter. So let's forget about this right now. But if they gave us the values in meter, then we have to change it. So here it will be 4 times 4, 16 pi. And the answer will be 25 over 16 pi. And the answer will be 0.497. Which one is the closest value? It's the first one. Okay.
But can you explain for the pi one? I do not understand.
Okay, this one, yeah? You mean this one?
Yeah.
As a formula, if you have a circle, the area of the circle will be pi r square. This is rule number 1. All right?
Yeah.
Okay, the number pi is just 3.14, 15, etc. It's just a big number. We use pi to make it easier. but it's easy if you can use the calculator. And to find the area, substitute the
There
value.
is pi in the calculator.
Yeah, you can find it on the calculator, even though maybe on my laptop, I'm not sure if it's available here. Let me check, but on the calculators, it's available. Or you can substitute 3.14. Let me go for the scientific one. Okay, look here. Can you see this one on my calculator?
Yeah.
Okay, once you press pi, it shows 3.141592, etc. It's a big number. But if you want, you can just use 3.1415. It's enough to give you the correct value.
The pi is in statistics or run matrix or equation.
It's in scientific. Look here. No need for the other parts of the calculator, just not the standard, the scientific part. I'm not sure about the type of calculator you are using.
I have CG50 FX. CG50.
50. I'm not sure if you can send me a picture. I will
The
just
one with the screen.
Can you take a screenshot for the calculator and send it as on my phone?
Okay.
Once you finish, if you want.
Now I will send.
يلا. Okay, let me check the. Okay, it's great calculator, by the way. Look here, can you see this one here?
Yes, yes.
It's the pi.
I have to press shift.
Yeah, for sure. Press this one with this one, and it will give you the value 3.14, I guess. Is it working?
1 second.
Okay.
I don't know where is the normal one.
What do you mean by normal one?
Normal solving. Is it equation?
No, not equation. Uh, try the equation. Try.
It shows simultaneous polynomial solver and solver.
By the way, can you go up with this screen? Can you see my screen first of all?
Yeah.
If you go up with this arrow, is there any other options?
No, that's it. And
So
then
you
there is down.
type down. Is there different options from these?
There is Python, geometry, 3D graph, conversion. That's it.
Try to send me another picture for the other options down. Maybe one of them. Maybe.
Okay.
Second.
I sent.
Yes. Okay. If I just take a look for the two pictures that you have sent to me, look here. Here you have 5, 6, 7, 8, 9. If you go for the 4, 3, 2, 1, it's going to be there.
To the fifth?
So can you see this number 5 and 6, 7, 8 till 9?
Yeah.
Sure, it's going to be before the number 5.
Before the number 5.
Yeah, if you go just backwards, you will find it. The normal solving.
Spreadsheet. It's before 5.
4, this is the 4.
Yeah.
And the 1.
Run matrix is the one. Run matrix.
1,
I
2,
found.
3, 2, 3.
Huh?
And 2 and 3, what are they? Number 2 and number 3.
Number 2, statistics and E
Oh,
activity.
I guess
It is a run matrix. It is a run matrix. I found it.
Oh, really?
Yes.
Test. Try it.
What do I write with pi?
Yeah, just write pi and equal. Don't forget to press shift.
It gave me pi.
Press the here. There is SD. Maybe this. Give me a second. Okay, this SD here. Try to
Yeah,
press this SD.
3.14. 3.14.
Okay, okay, it's good. That's it. So, in order to solve the pressure, you must find F and A and substitute the values, and you will get here the 0.5 is the correct one. Okay.
Okay.
Okay. Let's check if there is any other options. Okay. So now I will move to the previous exercise that we started with yesterday. Be careful once the time ends up after 2 minutes and 13 seconds. You must wait for 9 or 10 minutes and then we'll go for the direct session after this direct, okay? And
Mr. I
yeah,
cannot know. There is a prayer. Friday.
repeat, please. The sound is not clear here.
There is prayer now.
Yeah, yeah. Oh, you have different timing between us and you. Okay,
Yeah.
okay. How many minutes do you still have?
10 minutes.
Okay, so we will finish the session and you can go for that, okay?
Okay.
Okay, okay, great. So let's take the last part that we started with yesterday. Okay, yesterday we said that if we have this object, then the forces acting will be, one of them will be the tension acting on this wire upward on the rod. The other force will be the weight, which is this one, downward, and the weight of the rod, which is also will be acting downward. And since they have the same weight, 10 and 10, then we will have 10 Newton here, 10 Newton here, and here we have a tension. This is that we ended up yesterday, okay?
Okay.
Okay. Now, the new idea that we will start with, let me just first of all show this one. Okay. Here, the tension that we wrote or that we have shown here in this wire, it's made up of two vectors, x and y. So one of the vectors will be vertical and the other will be horizontal. And we said that here there is no angle, so we just not use the sine. Here there is an angle, we use the cosine. You remember that?
Yeah.
Okay, great. Now let's move to the